Okay, this is example 8 on page 110. So you're given this diagram. Sphere A, mass 1 kilogram, collides with sphere B of mass 2 kilograms. Just before impact, A is moving with a speed of 4 meters per second at 45 degrees to the line of centre. B is moving at speed 3 meters per second at 60 to the line of centres as shown in the diagram, and the coefficient of restitution is 3/4, and we want to find the kinetic energy lost in the impact. So you need to really think about what directions A and B are going to be moving in after the impact. So anything perpendicular to the line of centres remains unchanged. So they're both going to have this vertical motion going upwards. They're coming in together, and so we tend to model these as afterwards coming apart. It's possible they could be coming in and they could kind of knock off that way, but I would go with coming in, going apart for these, and so we can put A is going, I don't know, this direction, not quite sure how it's going to look, and B off in this direction. So the vertical component of the velocity remains unchanged. So this here is going to be 4 cos 45 and this bit here is going to be 3 sine 60. So that's coming from here as being 3 sine 60. Did I say sine 6? Did it be sine? Sorry. I meant sine there, didn't I? It's because it's 45, it's throwing me. So 4 sine 45 gives you that opposite, and 4 cos 45 gives you the adjacent. Sorry, I don't mean to confuse you. And then this one is 3 sine 60 to give you the opposite. And then the bits that we don't know are here and here. So we can call those V and W. So it's the stuff parallel to the line of centres that we've really got to think about working out. So we're writing in positives here. If one of these comes out negative at the end, then you know that actually your diagram was wrong. And I'm taking this direction as a positive direction. So that parallel to the line of centres, so we're looking at momentum. So momentum before parallel, we've got 4 cos 45 going in this direction. So that's my positive. And then minus 2 times 3 cos 60. So mass times velocity. I could have put a 1 times there, I just didn't bother because it's 1 kilogram. And then afterwards, that's equal to, so we've got this going positive, and that's mass 2 kilograms, and then minus V, because that's going in the negative direction. And so from there, 2 root 2 minus 3 is equal to 2W minus V. So that's our first equation. And then using restitution, so that E times the approach speed, which we're dealing with speed now, remember, so it's 4 cos 45 plus 3 cos 60 is equal to the separation speed, which is going to be V plus W. And that gives you the second equation. So 6 root 2 plus 9 over 2 is equal to 4v plus 4w. I would just whack that into a calculator. Don't be shy about putting these sort of things into a calculator. You're expected to. And so w comes out as being 1.025 and v is equal to 2.221. To find the change in kinetic energy, you can either work with the speeds as a whole, or you can just find the change in kinetic energy along the line of centres. For this one, I've actually used the actual speeds of the balls, not the components. So change in kinetic energy, I've got a half times 1 times 4 squared plus a half times 2 times 3 squared. So that's the kinetic energy before. And that comes out as 17 joules. Kinetic energy after. So you will need to just do a little bit of Pythagoras around there. So V is 2.221 to find the speed afterwards. And that comes out as being 3.596. And then a half times 2, same thing around there, gives you 2.793. And that gives you 14.27 joules. And so the kinetic energy lost is the difference between the two. Just make sure you don't get a rounding error. But that comes out as being 2.73 joules on that one. And then the last bit of the question is find the impulse exerted by A on B. Let's grab a new board, sorry. So I could probably do that, hopefully. The impulse exerted by A on B is the change in momentum of B. So for B, momentum afterwards is 2 times W, which is 1.025. And then the momentum before is 2 times, remember now we're working with velocity, so you just need to be a bit careful whether it's speed, velocity. Momentum is velocity, and so it's minus 3 cos 60 because it's acting in the negative direction. So momentum after minus momentum before, and that gives you 5.05 Newton seconds for the impulse exerted by A on B. So you're expecting that to go in the positive direction. And then the impulse exerted by B on A will be minus 5.05 Newton seconds.